Good morning. Today we are going to discuss the topic centroid. What is centroid and what is the difference between centroid and the center of gravity, how it is calculated. These things and all we are going to discuss in today's session. First of all, we will go on to the introduction of the definition of centroid. How can we define the term called centroid? Centroid is nothing but one small point in which the total area of the lamina is being focused. Okay, it's nothing but let's take one object. Here this is called not a lamina. Let's consider this as a lamina. Here we can have number of points here, wherever it is. But the total area of the lamina is being balanced by at one point. That point is called centroid. So centroid is physically for two-dimensional object and only for lamina. Lamina is nothing but it is a weightless object. Okay. And how can we get the point for centroid for different dimensions? Okay, let's say the shape. Let's take a square and let's have a rectangle and one right angle triangle. And finally, let's have a circle. Okay. Now let's have four different geometries, and in which point the total area of the geometry is being focused or concentrated. Okay. Let's have the square. Square having all the sides are equal. So let's have this is A, all the sides are equal. First take the size A, and moreover it is symmetry. What is symmetry? Symmetry is nothing but if you fold, okay, if you fold two things, let's have this two hands, okay, if you cut vertically, okay, then it will come like this. You fold like this, okay, so both will point everything each other perfectly. That is called symmetry, either in vertical axis or horizontal axis or both axis. Okay, so one axis symmetry is there as well as two axis symmetry is there. Okay, for square you can have a cut left and right, you fold, okay, both will point to each other. So it is symmetrical with respect to y axis, as well as you cut in the horizontal direction, so both up and bottom both will coincide with each other. So square is a geometry and having symmetry of both axes, both x and y axis. Okay, so this point, actually this point is the centroid. Okay, so it must be a center point. So here it will be a by 2 in horizontal way. In vertical, this is also a by 2. So for a square, I can have this point G. Let's have center as G here of a by 2 comma a by 2. Okay, centroid a by 2 comma a by 2. That means at the half of the horizontal distance as well as half of the vertical distance. Okay, that point must be called as the centroid for square, since it is two axis symmetry. Okay, for rectangles, same way, let's have breadth and depth. Both will have this symmetry as well as horizontally both axes are symmetric. So must be this one is called centroid, and it must be a center point of horizontal dimension as well as vertical dimension of b by 2, half of the distance. Okay, so center point for square and rectangle. Since it is two axis symmetry, the center point in x axis as well as y axis must be the center. And let's have our this one for a circle having diameter. Okay, having diameter d. Shall we have this is one axis symmetry? Okay, as well as horizontal it is also symmetry, two axis symmetry. Is a two axis symmetry or any other thing is there? First, let's consider this is a multi axis symmetry. If you cut lines also. Okay, so this side and this side both will fold. You just fold together, both will coincide with each other. In anything which passes through this center point is called. Okay, this is center point. So this is the point called centroid. So diameter by 2 and diameter by 2. Okay, so these are the centroid for the symmetrical axis. But for right angle triangle, let's have this is base, this is height. Here, how can we get the value? The centroid. Okay, the centroid is maybe here or here, there. Okay. But there will be some definition is there, but I will give you the final result. Okay. So here the centroid is from this vertex, it is 1/3 of the base. 1/3 of the base, and this height vertically it is 1/3 of height. So I can say that this is b by 3 comma h by 3. This is the center for a right angle triangle. So in this class we have dealt with what is the definition of a centroid. So here we are focusing on the lamina, so area is being considered, and what are the different geometries centroids for square, rectangle and circle as well as the right angle triangle. Since right angle triangle is not a symmetrical one, so it is not the exact at the midpoint, it will be the centroid. Okay, so we will see in the next class another topic. Thank you.